Give me your 5 minutes and I'll make bile pigments very easy for you to understand and remember for the longer run of your life. Now, bile pigments are coming from the breakdown of red blood cells. We all know when the red blood cells break down, they produce two things, heme and globin. The globin part which is there, it is reutilized by the body. The heme is not only produced from the breakdown of red blood cells, but it is also coming from the breakdown of hemoproteins, which are nothing but specialized proteins that have got iron as a cofactor. Example being myoglobin, catalase, peroxidase, cytochromes, etc. Now, once this heme is collected in the body produces an enzyme known as heme oxygenase, which further breaks down heme into two things, iron and porphyrin. Now, one thing I want you to remember is heme. The structure itself is made up of centrally placed iron with four pyrrole rings. So once it is broken down into iron and porphyrin ring. The iron which is produced here is utilized by the body again, or it is stored in the form of ferritin or hemosiderin. The porphyrin which is there under the effect of this enzyme is converted into biliverdin. Now, biliverdin is a very unstable component and it is acted upon by an enzyme which is known as biliverdin reductase, which produces bilirubin. This bilirubin is unconjugated bilirubin. The reason it is called unconjugated bilirubin is because it is extremely fat soluble and it cannot be removed from the body very easily. So for the body to excrete bilirubin, it needs to convert bilirubin into something which is much more soluble and easy to remove. So what the body does is it takes this bilirubin, binds it with albumin and transports it to liver cells, which are nothing but hepatocytes. Now once this unconjugated bilirubin has reached the hepatocytes, it is acted upon by an enzyme which is known as UGT, which is UDP glucuronylyl transferases. Now this enzyme converts bilirubin into something which is much more soluble, or something which we will call conjugated bilirubin, by attaching glucuronic acid with bilirubin. Now the first that it produces is bilirubin monoglucuranoid, which is produced to a percent of 20. Now under the effect of same enzyme, two molecules of glucuronic acid attach with bilirubin, giving us something known as bilirubin diglucuranoid, which is produced to an extent of 80%. Now, both these structures are called as conjugated bilirubin because it is easier for the body to remove them or excrete them through bile into the intestine. Now, majorly this is produced to 80%, as I've already mentioned. This is then further carried into the bile, and from there it is carried into the small intestine. From small intestine, it is carried into the large intestine, where it meets the bacteria which is present in the large intestine. This bacteria then breaks down this bilirubin diglucuranoid and produces something known as urobilinogen. Now, urobilinogen is the end product of all of this that we have studied, from the breakdown of RBCs, breakdown of hemoproteins, and from the metabolism of bilirubin diglucuranoid. This urobilinogen has got three fates. Some of it is going to be carried forward from the large intestine and excreted into the feces as toccobilinogen. Some amount of it is going to enter the enterohepatic circulation, where it is going to reach the liver again and reutilized. Some of it is going to enter the systemic circulation, from where it will find its way into the kidneys and removed as urinary urobilinogen. I hope this was very easy for you to understand and remember. For more or for any doubts on this, feel free to reach out.